Hello, we're going to go over the notes 522. What is a logarithm? Defining the inverse of an exponential function. The learning target is to rewrite expressions and equations using the definition of a logarithm. So the way the notes start today is that we're giving a table and we have to fill in the missing values. Now, it's really difficult to figure out the pattern of this table unless you think about the outputs as the inputs and the input as the output. So in other words, looking at the output first and trying to work backwards and see how to determine the input. And the pattern that we determined in class is that the input is a base 2 raised to the output exponent. So for example, you take 2 and you raise it to the third power, you get 8. You take 2 and raise it to the fifth power, get 32. Okay? Take 2 and raise it to the second power and get 4. Take 2 and raise it to the fourth power, you get 16. So that is the pattern that we determine. When you have a negative exponent, 2 to the negative 1 power, you get 1 half. Sometimes you get a decimal, and sometimes it does not exist because, for example, 2 to what power gives you 0? There aren't any exponents that when you raise 2 to that exponent, you get 0. Same thing with negatives. You cannot raise a base to any exponent and get a negative. Okay, so then we continued to over here where part A was asking to write the equation in exponential form, x equals 2 to the gx power. And we can rewrite this exponential as a logarithm with base 2. So g of x equals log base 2 of x. These two equations are equivalent. Okay, so we're going to be getting more familiar with the log equations. The way that I explain this in a separate class is that to go from logarithm to exponential, you have to take the base and raise it to the faraway exponent and then bring it back. So 2 to the power of g of x equals x. 2 to the power of g of x equals x. C and D are, well, actually, letter C is showing that there aren't any exponents that will give you 0 or a negative as an answer. So they do not exist. And then sometimes you get decimals. For example, 25 equals 2 to the power of g of x. G of x is going to have to be a decimal in order to bring the 2 up to a 25. And you can use your best guess using a calculator, 4.65. Here's another table, and we have to figure out the pattern again. And this one's a little easier to see because it's in order from decreasing to increasing x values. And same thing with the g of x values. This time the base is 5, and we have, for example, 5 to the 1 power is 5, 5 to the second power, third power, fourth power, etc. 0 power, negative 1, negative 2 power. Everything in between is going to be a decimal. So next, we're asked to, again, rewrite this as an exponential and then a logarithm, log base 5, okay, of x equals g of x. When you graph log base 5 of x, you can, again, use the table that was given, plot those points. You're going to see that it increases, but it increases at a decreasing rate. It's slower and slower and slower, even though it's still increasing. And then it goes down forever. It will not cross this y-axis. There we have an asymptote. Okay. As x increases, g of x increases at a decreasing rate. Logarithms are used to model things in real life that grow really, really slowly. The back of the notes. So we have some practice problems where we have to determine the value of certain logarithms. 2 to the power of what gives you 32. You rewrite it as an exponential and you realize that the exponent has to be 5. So log base 2 of 32 is equal to 5. You can rewrite log base 2 of 32 with just the number 5. So I made a side note right here. For example, log base 2 of 4, that is equal to 2 because 2 to the second power gives you 4. So this whole thing is equivalent to 2. Here it is again. That's equivalent to 2. So 2 plus 2 equals 4. This is just another way of writing the problem 2 plus 2. So anytime you have a logarithm where you know all the numbers, you can rewrite it with its equivalent value. 2 to what power gives you 1 half? 2 to the 1 half power. Sorry, 2 to the negative 1 power gives you a half. 2 to what power gives you 4? The answer is 2. 2 to what power gives you 0? You cannot get 0 if you raise 2 to any exponent. Here we're going to get 2 to the third power is question mark, so 2 to the third power is 8. 2 to the 1/2 power is question mark. 2 to the 1/2 power is the same as writing the square root of 2, which simplifies to about 1.41 if you round. 2 to what power gives you 1 over 16? Since it becomes a fraction, the exponent has to be negative. Okay, negative 4 because 2 to the fourth is 16. Fraction means negative. 2 to the 0 power is always 1. Here we wrote the powers of 2 just to, it's a good idea to kind of have these in the top of your head. You could always come up with them if you need to on the spot as well, just by doubling every time. Okay. Here we have to determine the inverse equation in y equals form. So in other words, find the inverse and make sure you have y by itself. To find the inverse, we have to replace the y and the x. So instead of y, we put x. Instead of x, we put y. So we have x equals log base 9 of y. We can rewrite this as an exponential as 9 to the power of x equals y. Y equals 9 to the power of x. Here again, we change the x and the y, and we write in log form, okay? Log base 10 of x equals y. 10 to the power of, so 10 to the power of y equals x. 10 to the power of y equals x. Okay, if you have more than one thing in the inside the log, you do the same steps. So flip the x and the y to find the inverse, and then 6 to the power of x is going to equal y plus 1. 6 to the power of x equals y plus 1, minus 1 on both sides to isolate your y because we want it in y form. Y equals 6 to the power of x minus 1. Last one, y equals 5 to the power of 2x. Here our exponent is composed of the product of 2 and y. So we change the x's and the y's, and then we write this as a logarithm. Log base 5 of x equals 2y. Okay, 5 to the 2y power equals x. Divide by 2 to isolate y, you get y equals log base 5 of x divided by 2. We ended the notes by doing some more practice problems. Log base 7 of 49, that by now should be pretty easy. To what power do I raise 7 by to get 49? The answer is 2. You can rewrite this whole thing as 2. Log base 3 of 81, what power do I raise 3 by to get 81? The answer is 4. What power do I raise 5 by to get 5 to the 7th power? This one looks kind of weird, but it's actually pretty easy because if you write this as an exponential, 5 to the question mark power equals 5 to the 7th. So if the bases are the same, the exponents must be the same. So question mark must be 7. What power do I have to raise 5 by to get 5 to the 7th power? Well, the power that you have to raise it by is 7, because 5 to the 7th is 5 to the 7th. So anytime the base and this base are the same, you can kind of cancel them out, and your answer will be just the remaining exponent. Like in letter D, log base 10 of 10 to the 1.2 power. You can cancel log base 10 with the 10, and your answer would just be the exponent 1.2. You could also rewrite this as 10 to the 10 to the question mark power equals 10 to the 1.2 power. So the bases are the same, the exponents are the same. Log base 2 of 2, oh, there you go. Log base 2 and 2 cancel out. Your answer should just be w plus 3. You could rewrite this as 2 to the question mark power equals 2 to the w plus 3, and then bases are the same, exponents are the same. But again, you can just use the trick, cancel out, and the w plus 3 is your answer. Anytime you have a base right here and a copy of it right here, the log base and that number or letter cancel out, and your answer is the exponent.